The situation given in this question is there is a point source which will be object for us. It is kept at a distance of 35 centimeters from pole of a concave mirror whose focal length is 25 centimeters. The question asked is where we have to keep a plane mirror so that the final image found by the plane mirror is coinciding with the object which we are taking here, which is the point source. So first reflection is going to be at spherical mirror, second reflection is going to be at plane mirror. First let us see what this concave mirror is going to do, where the image is going to be found. For that, the location of image can be found out by mirror formula, which is 1 by v plus 1 by u is equals to 1 by f. So substitute the values here. U is minus 35 and f is minus 25. You can check the calculation here. V will be is equals to 35 into 25 divided by 25 minus 35 minus 10, 5, 2. So 175 by 2, which will be minus 87.5 centimeters. Focal length is given as 25. Radius of curvature is 50. 87.5 will be beyond the center of curvature. So this concave mirror is going to form an image somewhere beyond the center of curvature. Let us assume this is the location of image found by the spherical mirror. And as for the mirror formula, this distance is 87.5 centimeters. If I take a ray diagram, from this object I am taking two incident rays. One incident ray along the parallel axis, principal axis. It will be just retracing its path and coming back after hitting here at the pole. One more incident ray somewhere here. If you draw the normal here, that has to pass through the center of curvature. So ray will be reflected on the other side, and this is second reflected ray. These two reflected rays are going to meet at this point, right? Now I have three regions where I can place a plane mirror. I can place a plane mirror between the pole of the curved mirror and the object, or I can place it between the image found by the spherical mirror and the object, or beyond the spherical mirror. Let us see where there is a chance that the image found by the plane mirror is going to interact with the, or going to form at the same place where the original object is placed. If I keep the plane mirror here, these two incident rays, these two reflected rays from the spherical mirror will act as incident ray here. They will be reflected and image will be formed somewhere here. No chance of coincidence with the original source. So this is not the region where I have to keep the mirror. Second, between the object, original object, and the image found by the spherical mirror. Here, this will act as one of the incident ray. This will act as another incident ray for this plane mirror. So it can be reflected, and there is a chance that the image can be formed at the position of the original object. If I keep it somewhere here, these two will act as incident rays and image will be formed behind it. So again, no chance of coinciding with the original source. So one thing is clear, I have to place the plane mirror somewhere between this image formed by the spherical mirror and the object. So let us assume this is the location of the plane mirror. It is not exactly coinciding with C, and I don't know whether it is behind C or before C. I am just taking an arbitrary position. Now for this plane mirror, the reflected rays from the spherical mirror are going to act as incident rays. This is one of the incident ray, this is another incident ray. So incident rays are converging in nature. So this image formed by the spherical mirror is going to act as a virtual object for this plane mirror. When in plane mirrors, if the object is virtual, then image formed will be real. Means these two incident rays should reflect and get converged at this point so that the given condition is satisfied. We know that for plane mirrors, the distance of the object from the mirror and distance of the image from the mirror should be same. You can see this total distance. This total distance will be 2x plus 35, which we have calculated as 87.5 centimeters. So from here 2x will be is equals to 52.5, which implies x will be is equals to 26.2 25 centimeters. So once I know the x, I know the position where I have to place it from the pole of the mirror. From the pole of spherical mirror, the distance will be is equals to x plus 35 centimeters, x plus 35 centimeters, which will be 61.25 centimeters. That will be the solution for this. So we will see the next question.